Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you like my videos and you find them important to your studies, also please don't forget to subscribe. Analyze the rigid frame shown by slope deflection equations by determining the support reactions and member forces. EI is constant. Also construct the shear force diagram, the bending moment diagram, and the elastic curve. So here is the figure, and for this subject, this is the last example that I'll present. Future example would be two-story frame with side sway, and I think many will not find it interesting anymore because of the so many unknowns and lengthy solutions. So for me, this is the last one and the best one. There are five unknowns in this problem. So because the load is at B, the horizontal side sway of joint B will be greater than that at D. So let's have the exaggerated configuration as shown. So this is delta 1, and the new position of B would be at B1. So that's delta 1. Then from B1 we draw a line parallel to BC, and let's call that B1 C1. Also, the resulting side sway for column DE would be delta 4 as shown, and it is lesser than that of delta 1 because it is far from the loading which causes side sway to the right. And the principle is we also draw from D1 a line parallel to CD. But before that, we have to draw a line from B1 parallel to BC, and let's call that C1. Then supposedly from C1, we draw line perpendicular to it to locate the final position of C. But before that, we draw a line also from D1 parallel to CD as shown. So let's call that point C2. So distance C2 is equal to delta 4, while distance C1, because B1 C1 is parallel to BC, is delta 1. Therefore, the distance between C2 and C1 horizontally is delta 1 minus delta 4. So let's locate the final position of C. From the end C1, we draw line perpendicular to C1 in that direction. And from C2, we draw a line perpendicular to C2D1 or perpendicular to CD to locate the final position of C. And we will call that final position of point C as C sub F as shown. And let's enlarge that triangle to relate the displacements or the side sway. I'll call this theta 2, opposite to the 3, adjacent 4, so the hypotenuse is 5, which is also the length of member BC. I'll call this theta 3, opposite is 3, adjacent is 7.2. The length or the hypotenuse is square root of 7.2 square plus 3 square. So this is now the enlarged triangle. This triangle here, C2, C1, CF, opposite to C2 would be delta 2. So this is delta 1 minus delta 4, distance between C2 and C1. So this is delta 2, while opposite of C1 is delta 3 for side sway of member CD. Then we draw line from CF down. So remember that the angle of inclination theta 2 is also the angle between the line perpendicular to BC, which is CF-C1, and the vertical. So therefore, if we drop that vertical, this is theta 2, and therefore this is theta 3, because this is the angle between the line perpendicular to CD, this is C2F, and the vertical. This is the vertical, so this is theta 3. So theta 2 is arctan of 3 over 4, so it is equal to 36.87 degrees. Theta 3 is arctan of 3 over 7.2, inverse tangent of 3 over 7.2, so 22.62 degrees. So therefore, theta 2 plus theta 3, or the measure of this angle is, this one is 90 minus theta 2. So 90 minus 36.87 is 53.13 degrees. This is 90 minus theta 3. So this is 67.38 degrees. So the measure of theta 2, 3, the angle at CF, is the sum of these two angles. So that's 59.49 degrees. Then by sine law, to relate the displacements or the angle, P1 is delta 1 over 6, P sub 4 is delta 4 over 6. Therefore, delta 1 minus delta 4 is 6 P1 minus 6 P4, as to sine of, by sine law, 6 of quantity P1 minus P4, that's delta 1 minus delta 4, as to sine of 59.49 degrees, equals delta 2 as to sine 67.38 degrees, equals delta 3 as to sine 53.13 degrees. So delta 2 in terms of P1 minus and P4 is equal to 6.4285 quantity P1 minus P sub 4, and therefore P sub 2, or delta 3 in this case, is 5.5714 degree, 5.5714 quantity P sub 1 minus P sub 4. So P sub 2 is delta 2 over length, which is 5. So 6.4285 quantity P1 minus P4 over 5. And that can be expressed as an exact value, negative 9 over 7 of quantity P1 minus P4. So that's it. And it is negative because the rotation or the side sway is expected to be counterclockwise. So by slope deflection equation, counterclockwise rotation is negative. So that's it. So from B1 to CF, that's the chord rotates counterclockwise. That's why it is negative. While from CF to D, it is, or D1, it is clockwise, so it's positive. So therefore, P sub 3 is positive. It is equal to 5.5714 times P1 minus P4 divided by length, which is square root of 7.2 square plus 3 square. And it is equal to 5 quantity P1 minus P sub 4 over 7. So we then set up moment equations. MAB equals 2 times EI1 over L6 quantity 2 times 0 plus theta B minus 3 times P sub 1. So this is P sub 1, the rotation of chord AB1 or AB, which is clockwise. So MAB is equal to theta B over 3 minus P sub 1, call that equation 1. Then MBA, because it is B that is doubled, so 2/3 of theta B minus P sub 1, equation 2. MBC is 2/3 of 1 over L5, quantity 2 theta B plus theta C minus 3 times P sub 2, which is negative 9 over 7, quantity P1 minus P sub 4. There's no fixed moment, there's no load. So MBC is zero point 0.8 theta B plus zero point 0.4 theta C plus 54 over 31 P1 minus 54 over 35 P1 minus 54 over 35 P sub 4, equation 3. MCB, interchange coefficients between these two first terms, then copy the last two terms. So MCB is zero point 0.4 theta B plus zero point 0.8 theta C plus 54 over 35 P sub 1 minus 54 over 35 P sub 4. Call that equation 4. Then MCD is 2 times 1 over 7.8, the length of CD. Quantity 2 theta C plus theta D minus 3 times 5 over 7 of quantity P1 minus P sub 4 for P sub 3. Simplifying, MCD equals 20 over 39 theta C plus 10 over 39 theta D minus 50 over 91 P1 plus 50 over 91 P sub 4, equation 5. So therefore MDC, the shortcut is interchange the coefficient of these first two terms, copy the last two terms. So 10 over 39 theta C plus 20 over 39 theta D minus 50 over 91 P1 plus 50 over 91 P sub 4. Equation 6. Then MDE is 2 times 1 over 6, quantity 2 theta D plus 0 minus 3 times P sub 4. So simplifying, MDE equals 2/3 of theta D minus P sub 4. Therefore MED is 1/3 of theta D minus P sub 4. 2 times theta E, but theta E is 0, so plus theta D, so MED is theta D over 3 minus P sub 4, equation 8. Then we apply equilibrium at joint B. MBA plus MBC equals 0. So MBA is 2/3 theta B minus P1. Then MBC is 0.8 theta B plus zero point 0.4 theta C plus 54 over 35 P1 minus 54 over 35 P sub 4 equals 0. Combining like terms and setting up the first equation A. So 22 over 15 theta B plus 0.4 theta C plus 19 over 35 P1 minus 54 over 35 P sub 4 equals 0. Call that equation A. Then at joint C, MCB plus MCD equals 0. So MCB 0.4 theta B plus 0.8 theta C plus 54 over 35 P1 minus 54 over 35 P sub 4 plus 20 over 39 theta C plus 10 over 39 theta D minus 50 over 91 P1 plus 50 over 91 P sub 4 equals 0. Combining like terms and then setting up equation B, we have 0.4 theta B plus 256 over 195 theta C plus 10 over 39 theta D plus 452 over 455 P1 minus 452 over 455 P sub 4 equals 0. Call that equation B. And let's continue this on the next slide. Let's have equilibrium at joint D, MDC plus MDE equals 0. So let's have MC MDC plus MDE equals 0. So 10 over 39 theta C plus 20 over 39 theta D minus 50 over 91 P1 plus 50 over 91 P sub 4 plus 2/3 of theta D minus P sub 4 equals 0. Simplifying, setting up equation D, 10 over 39, equation C rather, plus 46 over 39 theta D minus 50 over 91 P1 minus 41 over 91 P sub 4 equals 0. Call that equation C. Then let's have equilibrium for the entire system. Summation versus x equals 0. So these are the assumed directions for shear and reactions at A and at E. So summation versus x equals 0. VA plus V sub E plus 60 equals 0. So VA is, if you draw the free body diagram of column AB, remember by experience, it is 1/6 of MAB plus MBA. So 1/6 of quantity MAB plus MBA plus 1/6 of quantity MED plus MDE equals negative 60. So multiply everything by 6, substitute the value of MAB, MBA, MED, and MDE. So theta B over 3 minus P sub 1 plus MBA 2/3 of theta B minus P1. MED is theta D minus P4 plus MDE 2/3 of theta D minus P sub 4 equals negative 360. 6 times 60, negative 60. Combining like terms, setting up equation D. So theta B plus theta D minus 2P sub 1 minus 2P sub 4 equals negative 360. Since there are 5 unknowns, we have to think for another equilibrium equation from the free body diagram, and to do that, let's consider the figure shown. We consider on the BCDE, and let's have the shear reactions at B. Let's find a point of intersection between BC and DE so that we sum up moments there so that only the shear forces will have moments about O. So remember, this is 7.2, that's 3, 4, so 5 meters. Let's call that Y, call this Z. Then by similar triangles, these are the reactions and shears assumed. So 6 meters by similar triangles, Y as to 3 meters equals Z as to 5 meters equals 7.2, horizontal as to 4. So Y is equal to 5.4 meters. So 5 plus 5, this is 6 plus 3, 9 plus 5.4, 14.4. Distance of VE to O. Then Z is 9 meters. So 5 plus 9, that's 14. So summation moment O equals 0. So we have V sub E times 14 plus V sub E times 6 plus 3, 9 plus 5.4, 14.4. V sub E times 14.4, counterclockwise moment equals clockwise moment. So equals MBC plus MED. Substitute the value of V sub B, which is, if you draw free body diagram on BC, then there is MCB here. So V sub B is 1/5 of MBC plus MCB by experience. So 1/5 of quantity MBC plus MCB times 14. V sub B, likewise, if you draw the free body diagram of column DE, there is moment DC here, which is assumed to be DE rather, which is assumed to be clockwise. So V sub E is 1/6 of quantity MED plus MDE. So 1/6 of MED plus MDE. Then times 14.4 equals MBC plus MED. So combining like terms, simplifying 1.8 MBC plus 2.8 MCB plus 1.4 MED plus 2.4 MDE equals 0. Substitute the values of MBC, MCB, MED, and MDE. So 1.8 of MBC, which is 0.8 theta B plus 0.4 theta C plus 54 over 31 P sub 1 minus 54 over 31 P sub 4 plus 2.8 of MCB, which is 0.4 theta B plus 0.8 theta C plus 54 over 35 P1 minus 54 over 35 P sub 4. Then plus 1.4 of MED, which is theta D over 3 minus P4. Then plus 2.4 of quantity 2/3 theta D minus P sub 4 equals 0. Combining like terms and setting up equation E. So we have 2.56 theta B plus 2.96 theta C plus 31 over 15 theta D plus 1242 over 175 B1 minus 1907 over 175 B sub 4 equals 0. Equation A. So solving equations A, B, C, D, and E using Excel, because this is 5 simultaneous equations, I will not present the solution by reducing it to 3 equations in 3 unknowns. You may have it in your free time, but for this case, I'll just use Excel in solving for the 5 unknowns. So this is the result. These are the coefficients of the equations, then the constants. Everything is 0 except for equation D, which is negative 360 here. So by matrix approach, so we have this theta B, theta C, theta D, P sub 1, and P sub 4. Therefore, MAB is equal to theta B over 3 minus P1. This is theta B over 3, then minus P1. MAB equals negative 132.152 kilonewton meter. MBA is equal to 2/3 of theta B minus P1, so 2/3 of 108.929 minus 168.462. MBA equals negative 95.843 kilonewton meter. Therefore, MBC is positive 95.843 kilonewton meter. And let's continue with MCB, MCD, and so on and so forth on the next slide. So to continue, these were the results in the preceding slides, and the values of theta B, theta C, theta D, P1, and P sub 4. So MCB is 0.4 of theta B plus 0.8 of theta C, then plus 54 over 35 P1 minus 54 over 35 P sub 4. So MCB is equal to 19.003 kilonewton meter. Therefore, MCD is negative 19.003 kilonewton meter. Then we have MDC, which is equal to 10 over 39 theta D, theta C, plus 20 over 39 theta D, minus 50 over 91 P sub 1, plus 50 over 91 P sub 4. So MDC is equal to positive 40.916 kilonewton meter. Therefore, MDE is negative 40.916 kilonewton meter. Solving for MED, or computing for MED, which is equal to P sub theta d over 3 minus p sub 4. So MAD is negative 91.089 kilonewton meter. We then solve for the shear. So these are the actual directions because MAB is negative. So from slope deflection sign convention, it will be counterclockwise as well as MBA. So V sub A is 1/6 of MAB plus MBA. So 1/6 of 132.152 plus 95.843. So V sub A is 37.999 kilonewtons. Then for shear at B, let's look at the figure shown. So shear B should be going in this direction, and it is 1 over 5 because that's 1/5 of MBC plus MCB. So 1/5 of MBC, which is 95.843 plus MCB, which is 19.003. So shear at B is 22.969 kilonewtons. Then shear at C, let's have the moments first at C and DC. Counterclockwise, MCD is negative 19.00, so counterclockwise, while MDC is positive, so it is clockwise. So the direction for shear at C will be as shown, and it is 1 over 7.8. Remember, length of CD is 7.8, so it is 1 over 7.8 times quantity negative 19.003 plus 40.916. So shear C is 2.809 kilonewtons. Then finally shear at E. So we have the moment DE and moment ED, both counterclockwise because they are negative in the results. So V sub E is going to left. So V sub E is 1/6 of quantity 91.089 plus 40.916. So V sub E is 22.001 kilonewtons. So we are now ready to sketch the shear diagram, shear force diagram. So first, remember top fibers would be left, top, top, and in this case right. So first we have V sub A here, positive 37.999. Then constant, straight line up, it should close. Then we have shear B, which is in this direction, so negative 22.969. Then constant, then it should close. V sub C is also negative 2.0809. Then straight, that's also 2.89, closes. Then since shear at E is going to left, so shear at D should be going to right, which is equal to 22.001. Then straight vertical down, and it should close. So that's the shear force diagram in kilonewtons. For the bending moment diagram, we begin with negative 132.152, then negative 132.152 plus 37.999 times 6, straight, then we'll have 95.842. The expected value is 95.843, so that's very good. Then we begin with 95.843 minus 22.969 times 5, and we'll have here negative 19.002. The expected value is 19.003, so that's very good. then 19 negative 19.002 minus 2.809 times 7.8. Remember, this is 7.8. Then we'll have here negative 40.913. The expected value is 40.916, so that's fine. Then negative 40.916 plus 22.001 times 6. So we'll have here 91.09. The expected value is 91.089. So that's very okay. So this is the bending moment diagram in kilonewton meter. Finally, for the elastic curve, so we have concave down if we flipped our view, then concave up here, then concave up, then a little bit down, concave down, then concave up. So that's the approximated elastic curve as shown in the figure, and therefore that's the elastic curve. So that's it for this problem. The video is very long because the problem is also very challenging. So I hope you were able to follow the solution, and you can do slope deflection equations of frames with side sway, and you can also sketch the shear force diagram, bending moment diagram, as well as you can sketch the elastic curve.